Welcome to the Automating Plans with C# session. This class will be presented by Danielle DeTennis, the Structures Automation Engineer at WSDOT. My name is Rachel Burnham with SRF Consulting, and I'll be assisting with the Q&A moderation and have just a couple of notes before we start this session. We want to give a thank you to all of our sponsors for helping make this virtual workshop happen. We couldn't host this workshop without their contributions. Thank you. An evaluation link will be provided at the end of the session, and you'll receive an email at the end of the day. You'll need to complete the evaluation to qualify for PDHs, and it'll also help with future event planning. So now we'll turn it over to Danielle.
Welcome to Automating Plans with C#, the ACEC Civil 3D Users Conference. My name is Danielle DeTennis. I'm a structural automation engineer with the WSDOT Bureau of Structures Automation Policy and Standards Unit. I work on developing programs that help engineers and drafters design bridges, and often these tools are CAD related. I was also the sole developer for the WSDOT Standard Bridge Design tool. Today I will be giving a brief demonstration of the WSDOT Standard Bridge Design tool. I will introduce the Autodesk ObjectArcs programming environment and resources for learning. Then I will be going over a simple example where we will be creating a program that draws a bridge plan. Finally, I will cover potential benefits of developing C# tools for Civil 3D. The WSDOT Standard Bridge Design tool is a simple web interface that outputs a set of nearly complete single-span concrete slab bridge plans from 7 basic input parameters. There are over 12,000 combinations of bridges that this tool can handle. This program was developed entirely in C# and uses the ObjectArcs library to draft the plans in Civil 3D. This is the landing page for the Standard Bridge Design tool. This page isn't available yet because it's still in beta. Once it's available, you'll have to register for a username and password to log in. We hope to have this process finalized in the next few months. Once you've logged in to the WSDOT Standard Bridge Design tool page, this is what it looks like. There are only a few things that need to be filled in here. First, you have to select your project type, either state-let or local-let. Most things are going to be state-let. You have to agree to the terms of use displayed here. Then you have to enter a correct FIPS construction ID. There are only a few that are allowed, and they're entered into our database. If you don't have a valid ID, you won't be able to continue. It's recommended that you enter a design ID and structure ID because we record these for our records. So again, you follow the format here of, whatever the 8-digit ID is. So 1, 2, 3, 4, 5, 6, 7, 8, or whatever the number is. And then same with structure ID. So B, a 1, 1, 2, 3, 4, whatever. And then here are the 7 inputs for the slab. So you can have a span length between 24 feet and 48 feet at 2-foot increments, and then a substructure skew between -20 and 20 feet. So I'm going to pick a -20 and 20 degrees. So I'm going to pick a skew of -10 left-hand forward degree skew. And then a roadway clear width between 24 and 30 feet at 2-foot increments. So I'll pick a 30-foot. And then there are 2 barrier types here, 42SS and type M. So I'll pick type M. And then you can choose to have a paving notch or not. And then you choose the abutment height. 5, 6, 7, or 8. And finally, the pile type, either these two CIP cast in place piles or the HP steel pile. And then finally you hit get plan and it will download a zip file. So here's the zip file and it opens up, it will download a PDF. So this is what it downloads. So it will, it's a full plan set of 9 pages. So it's missing the subsurface exploration sheet, which you need to provide, but it has all the rest of the 10 sheet plan set. It marks in red what needs to be provided, but other than that, it's substantially complete. There may be other details that you'll need to add in if you have anything special about your plans, for example, pile points, or a special waterway detail, or other special details that need to be added to your plans. But other than that, it's pretty substantially complete. It has completed quantities. There are a few quantities that need to be added in, like the length of the piles are not added in, and the riprap quantities, because we don't know the details of how the stream bed is fitting in. And then you need to fill in details of how the profile grade line is fitting in. And then, for example, the abutment page is almost entirely complete with all of the rebar filled in. You just need to fill in details of the elevations, the length of the piles, and stuff like that. And again, the superstructure is pretty much complete. You just have to fill in which abutment, the roadway name, and which abutment, which direction the abutments are. And the rail, the type M railing is completely detailed as well. This is the drawing that the tool creates. It has multiple sheet layouts for all of the sheets. I think eventually I'm going to split this out into individual drawings instead. This is the way it is for now. You can see in the model view that all of these are complete dynamic dimension strings. So it's, you know, completely editable and easy to modify if you need to. These are also uses a lot of blocks. Some of these are dynamic blocks as well. So for example, if you double click this, it's got a lot of attributes in it, so you can easily modify the berm elevation, which is the blank that needs to be filled in here, and stuff like that. The barrier, for example, this part needs to possibly be taken out if there's not a tri-beam attachment, so that's really easy to just delete out if you need to. So we've tried to make it as easy to edit as possible. The AutoCAD ObjectArcs programming environment is what I use to develop the standard bridge design tool. It has object-oriented .NET application programming interfaces, or APIs, and its versatility made it an easy and possibly the only choice for the standard bridge design tool. Coming from MicroStation, this was quite a learning curve. There were still some downsides that required workarounds. For example, there was no direct object for multi-leaders. Here's some resources for learning. My first AutoCAD plugin tutorial is available on the Autodesk website to get started with the basics. I found the arx.chm file that comes with the ObjectArcs SDK incredibly useful. It contains a lot of example code. Autodesk has a dedicated .NET forum to search through old questions and ask new ones. Next, we'll go through a simple example where we'll develop a tool to draw a bridge plan. This example will use basic AutoCAD elements to draw a bridge. To simplify the example, I'm going to skip more complicated steps like applying layers, text styles, and dimension styles. Instead, I'll start a new drawing with the struct decimal start.dwt template and preset the text style and title, the dimension style to annotate, or text style to title and the dimension style to annotative. Also, the example will use easy to follow line by line code. This means some of the lines of code are repeated several times. In a real program, this will be extracted into multiple methods to be easier to maintain. So this is Visual Studio, and this is our example plugin. Visual Studio, if you haven't seen it before, is a program used for coding in primarily .NET, which is a collection of Windows languages. So this code is C#, and this is the commands.cs file, and this is primarily just this comes from the Autodesk wizard creates this file when you set up an Autodesk or a C# plugin for Civil 3D. So it creates all of this code automatically. So these are, you can create as many commands as you want. So these will create commands that you can type into Civil 3D. So I made a command here called ACEC example. So I can type this command into Civil 3D, and for this one, I'm going to make a view. So it's going to pop up this window here. So we want to make a little bridge plan. So it'll make, we want to control the length of the bridge, the skew of the bridge, and how wide the bridge is. And then we want a button to run the program. So I made this little window, and then we have the code for the window here. So going through this code, we have 3 variables here. We have the bridge span, the bridge skew, and the bridge width. So that matches the numbers we have in here, 16, 15, and 30. 16, 15, and 30. But the most important thing is what happens when we push run. So that's what we want to focus on, because that's where it actually hooks up to Civil 3D. So that's what I want to focus on with the example. So first we have to start a transaction with Civil 3D. So this code is always the same, and it's kind of like just nonsense to me. So I just basically copy it and use it the same way. What I do change is this doc and db. I always modify them. In a lot of the examples, they'll change it. They'll use longer variables. I like to shorten the variables up. So we're starting a transaction with Civil 3D. Next, what we want to do is set the annotation scale. So one of the ways that you can communicate with Civil 3D is by directly sending commands. So you can use the doc variable here, which is just the document, like the Civil 3D document itself. And then you can use the send string to execute method. So send string to execute, and you can see it pops it up there, so you can just hit enter. And then you can enter in any command you want. So I'm going to use the canoscale command. So that will set the annotation scale. And then when you're in Civil 3D and you set the you type in canoscale, you have to hit enter. So I'm going to simulate hitting enter by just typing /n. And then I'm going to type the name of the scale I want to input, which is 5.0. And then hit enter again. And then last, it needs to know if you want it active, true. Oops. So that will just basically enter whatever commands, and you can string as many of these together as you want. So this is one really simple way that you can just control Civil 3D. However, this is not the fastest way to do it because it will enter these one at a time. And it has to display everything that it's entering on the screen. So it's better to actually control Civil 3D itself when you can, using the transaction and the database. But for some things, you just can't, and you have to work around by using the send string to execute. So the annotation scale is one of those things where I need it to do it this way. So I'm going to copy in some more code and just explain through it. So next, I need to get the object context manager. And this is for controlling annotation scales. So I want, what this is for setting annotation scales on items like text and dimensions. So by default, when I create text and dimensions, they're all going to be set to 1:1 annotation scale. And I want to set them instead to 5.0 annotation scale. So this is how I get their annotation scale, is through the object context manager. The next step is to open up the transaction block table to add elements to the drawing model space. So again, I'm going to copy over some code and just go over it. So first we want to create a variable called block table, and we're going to use the transaction variable that we opened up here where we started a transaction, and we're going to get an object, and we're going to use the database object that we started over here using the document object. And we're going to get this block table ID object from the database. And then we're going to get a block table record variable using that block table object. So these are just, we're going to use these to be able to add elements to the drawing model space because we're opening this, or this block table record is in the model space of the block table. Next, we're going to add some text to the plan. So we're going to make a variable called title. and it's going to be an mText variable. And then we're going to add some properties to our new object. So first we want context, so contents. So this is just what the text says. So we want it to say plan. So this is pretty good, but in addition to just saying plan, we want it to be underscored. So to get it to be underscored, if you look in Civil 3D, it'll have these brackets around it. Finally, not only do we want it to be underscored, but we want it to be centered. So to get it to be centered, if you look in Civil 3D, you add this extra bit of code to the front of it. So this will make the text say plan, and it will be underlined and centered. Next, we want to give it a location. So I'm going to give it location, equals, and we're going to use point 3D, and we're just going to define a point. So we're going to put our bridge kind of centered. So we're going to put the text just a little bit below center. And finally, we want to set it to be annotated. Okay, next we want to use those object contexts that we defined before to set the annotative scale. So I'm going to copy some code again and explain what it does. So first, the first line of code is going to remove, or it's going to add context. It's going to add this 5.0 scale, OCC 5, and then the next one removes the OCC 1. So it's just setting this title variable to the 5.0 scale. And then finally, we need to add this title to the model space. So we're going to use this block table record, and we're going to append it. We're going to append the title object to that. And then we're going to take the transaction, and we're going to add the title object to the transaction. So these are the steps, these are all the steps you need to take to add an object to the database. You could do something similar by, sending strings to execute, and simulating clicking your mouse or something like that. But in the long run, it would take a longer time to emulate that when the program runs. This is much faster on the machine. Next, we're going to draw the outline of the bridge using the inputs from the text boxes. So I'm going to paste in some text again. So I'm going to get the bottom left and the bottom right. These are pretty simple. I'm just going to draw a line or make 2 points. So point 2D, this is going from the negative bridge span over to 0, and then positive bridge span over the 2, 0. Next, I have to make a variable called xskew to calculate how much the skew affects the top side of the bridge. And then I can calculate the points for the top left point and the top right point. Next, I can create a polyline. So a polyline obviously is just a shape, and I'm going to add a vertex for each of these points that I created. So first, add a vertex at point 0, and that's the bottom left corner. And then add another one at point 1, bottom right, another one at point 2, top right, top left, and then bottom left again to complete parallelogram. And then finally, I tell it that it is a closed shape. And then again, I repeat the same thing that we did up here, where I append the entity to the block table record, and I add the newly created object to the transaction. For the last part of the plan, we want to create 2 dimensions to show the length and the width of the bridge. So I'm going to create a new variable to store, first we're going to create the length dimension. So this is a rotated dimension object, and again, we're going to add some properties to this object. So the it's going to need 2 properties for the 2 points at either end of the dimension. Is there x line point 1 and x line point 2, or x line 1 point and x line 2 point. And again, these are point 3Ds. So we're going to draw these. We're just going to make a point between the center, between bottom left and top left. So I'm just going to copy the equation. And then we're going to do the same thing for x line 2 point. So that's just the center point between top right and bottom right. And then the other point we need is dim line point. And you can see that it's telling you here that specifies where the dimension line will be. That is the point that will be somewhere on the dimension line. So this specifies basically the height of the dimension. So we're just going to say that it's going to be we'll just put it 5 feet above the bridge width. So bridge width plus 5. And then last, we're going to make it annotated. And then we're going to do the same thing for dimension 2, but we're going to make this one measure the width of the bridge. So this one's much simpler because the first point is just going to be 0, 0, 0. And the second point is just going to be 0, bridge width 0. And then the dim line point, this doesn't really matter, but I'm just going to use halfway between these 2 points. And then an additional thing we need is the rotation of this one, because it's not 0. It's going to be 90 degrees. And we need to put it in radians, so that's math pi over 2. And then make it annotated. Right, and then copy in a lot of code here, but this just repeats all the stuff from the other ones. So add the 5 annotation scale, remove the 1 annotation scale, append the entity to the block table record, and add it to the transaction, and then do the same exact thing to dimension 2. And then last, we need to finalize the transaction. So we just do tr.commit. And then just so we can see what we've done, we're going to zoom in. I'm just going to paste this one. And this one's just a send string to execute. So zoom extends. And this is our code. So the last thing to do is just press start to run the code. So when you start the code, one thing you can do as well is you can you can set debug points, and that will allow you to pause the code at any point, and it will let you step through the code to see how it's running and evaluate it. So just wait for a bit for Civil 3D to start up. So once Civil 3D starts up, it's not going to run the code automatically. First, you have to load it. So to load it up, oh yeah, first I want to create a new drawing because I need to start it in the proper template. So I want to use struct decimal start. And then I also want to set the text style to title and the dimension style to annotative. Since I'm not covering how to set dimension styles and text styles, I'm just going to set them up to start with. So to start the tool, you have to type in netload. And then you have to navigate to the folder. So this is where I've stored the folder wherever you create your C# project. There will be a bin file when you create the debug, and in there will be a debug folder, and that's where the DLL library will be stored. So you have to load that DLL library. For mine, I called it example.dll. And now that that's loaded, I can run the command. So I called it ACEC example, and you can see it suggests it. And I hit enter. And now the ACEC C# example pops up. So I can hit run. And there we go. There is the plan. You can also try modifying this to different dimensions. Let's try 90, -10. Let's try -5 because that'll be more visible. And then 40. So there we go. You can see it'll draw whatever you tell it to. And then lastly, let's try complete. If you go into the code, you can click to add a debug stopper, and then when you run it, it will stop the code there, and then you can step through point by point. And then you can see, you can hover over variables and it'll tell you what the variables are at each location. So then if it's not drawing correctly, you can hover over, or you can step through and see why it's not drawing correctly. So for example, if this wasn't calculating correctly, for example, you could hover over it and see, and now you can see that the XQ is -3.5 approximately, and you could figure out why that wasn't being calculated correctly. So this is really useful, that it lets you debug it live like this. And then you can hit continue whenever you want to finish that up. So that is how you make a really simple bridge plan drawing in C#. Obviously, you can modify this to be a lot more complex. The tool that I made to draw an entire bridge plan is based off of these concepts. It continues to build off of this. Obviously, it makes it extracts the code a lot more, so it's not repeating code over and over again. But you can really do a lot with this code, and you can really gain a lot of efficiencies and automate tons of things with this. So there's a ton of potential if you're really willing to put in the resources for it. So what are the potential benefits of using C# to make AutoCAD plugins? Any repetitive workflow can be automated with enough resources. There are tedious workflows that often waste time in your work. It may save a lot of time in the long run to automate them. C# and ObjectArcs APIs are used to create many of the tools in the Wiz.Civil 3D package. Most of these tools are very simple but save thousands of button clicks over time. The Bureau of Structures will continue to take advantage of C# to automate our workflows, and we hope others will see the benefits too. If there are any questions, you can contact me at my email, and I'll take questions now.